Hello everyone, welcome to another class, another topic, and now we are going to talk about static source code analyzer. So basically we are entering a new topic. That's where we cover some tools that facilitate us to make it faster for us to do the same thing that we did before, the same type of vulnerability discovery, the same type of security analysis, but now in a much more automated way. So we are going to follow the normal flow of every class, giving some definitions, demonstrating some tools, and then finally in the end, we are going to have some demonstrations before we proceed to the assignments, right? So start with definition. What we are talking here today about the static source code analyzer, it's basically, first of all, static analysis tool, and this is an important difference to make. That is basically the fact that we have two types of analysis tools: static analysis tools and dynamic analysis tools. So static analysis tools are the tools that analyze the code without running the binary, right? So basically inspecting the code, reading the code and searching for the code, wrapping the code, this type of things. And dynamic analysis are the type of tools that actually run the code to analyze, right? So basically when you're debugging into GDB, as we did sometimes in this course, what we are doing, it's basically doing dynamic analysis. And during other parts of the course, when you're inspecting the code, I was explaining you the code on the screen, it was basically a static analysis procedure because we were analyzing the code without actually running them. Of course, there are pros and cons in each one of them. Dynamic analysis, as you saw, GDB allows you to inspect at a much more fine-grained level of detail, but it's also more expensive. You have to actually run, so it consumes more resources. And static source code analysis has some limitations. You actually can't modify the behavior of the program in runtime as you are not running, but you can still get a lot of it. So the cost benefit, it's pretty good because you don't have to have any particular tool to execute many tasks. You can simply inspect the code, try to understand how it works, and then you can get a good amount of information between that. So this is another one of the multiple trade-offs that we have been expecting in this course. And today we are going to talk about the static source code analysis tools because they help a lot to understand code in general, right? So basically, that's what we are going to cover today. This type of tools, static source code analyzers, they are used for a bunch, for a multitude of applications, including security applications, right? So basically, there are many benefits in doing this type of secure source code analysis, which include, as I said, the cost that's very, very cheap in comparison to other tools, the fact that by using a static source code analysis, you can anticipate the attackers, you can predict the bugs before the bugs appear in reality, so you can prevent them and patch as soon as possible. Because the idea that we are proposing here is that we are going to integrate these source code analyzers to our pipeline. So basically, we are getting the knowledge that we have about security, put this into a tool, and then make it available to everyone. Of course, the most famous known type of static source code analyzer is code reviews, right? So probably there is some human reviewing the code of someone else. This is very, very common. There are companies that have professionals completely dedicated to that. We have security code reviews as well. But security code reviews requires time. It's a time consuming. It's very error prone because someone needs to be very focused to find the errors, and requires expertise, right? Because you must be a security expert to do a security code review, right? Not only a normal programmer, but you need to be a security expert. So our idea here is to get all this knowledge, all this expertise, put it into a tool, and then make it available to everyone. So the chances of missing something are reducing because the application is doing there. The application doesn't get tired as a professional, right? And then, of course, we make this available to every programmer. The programmers now don't need to be anymore a security expert. They can be just yet another programmer, and then they can still benefit from the knowledge that we have about security via those tools, by applying those tools to their applications. And the idea is, of course, whenever we create a kind of tool like this, is not to replace the human analyst, the human expert, but to complement it. So the low-hanging fruits, the most common vulnerabilities will be handled by tools like this, and the analyst will be free to perform the more complicated, more sophisticated corner cases that just a human can identify, right? That's the idea. And here in these courses, I have been talking during the whole course. In many cases, you'll be the ones using the tools, but in many other cases, you'll be the ones creating those tools. So that's why we are giving all this, we are having all this conversation about how this tool works. So since we have benefits on creating a tool, making a tool available to anyone, and inspecting everything statically, let's see what we can do with this type of tool. So we can use these tools to detect a multitude of weaknesses, mainly for our interest here in this course, security vulnerability. So in general, these tools are able to detect many of the common vulnerabilities, and to a great extent. Of course, it's never 100%. There is always, as you saw, a different way the attacker can craft an attack, so creates a variation. But considering the most common cases, this type of source code static analysis tools are able to detect SQL injection, cross-site scripting, hard-coded the passwords, and similar kind of things. So all these most common things are detected in its most common variations. So it's pretty good, because if someone, a programmer, creates a vulnerable code without realizing, if you are immediately running this created code through a static source code analyzer, you are going to detect most parts of these most common, most trivial vulnerabilities, right? And as I said, later, an expert will go there to find the corner cases. But not only in security, this type of source code analyzers are also used in other places. As I said, code quality. So basically, what's the quality of the code, how this code is going, if it's following some standards or templates that they should follow, if they have documentation, all these types of things. Companies in general have this kind of Q&A, right? Quality assessment or assurance. So basically, there are professionals doing this from the software engineering community. Right now, what we are trying to do is to try to bring this to security as well, to have the security professional also running these quality checks from a security perspective, right? But there's also possible to do this from a performance perspective. There are people who are benchmarking the tools and trying to check the code to investigate where the code is problematic, where is the bottlenecks of a given code, or even simply errors that might have from, as I mentioned before, a safety perspective, right? So we can do this from a safety or security, as we investigated before. We discussed this in previous classes, but what we want to do here right now is to talk about the security part of it. So we are going to apply a tool that has security knowledge, and it's going to inspect statically the code to identify potential security violations. That is our goal, right? So basically, moving on to the next part. What we're going to talk about right now is about the applications. How do we actually use that? Because the idea, once again, I always present the big picture in the beginning. The idea is pretty clear, I believe. That's basically, okay, we're going to run a tool. The tool has security knowledge. The tool is going to detect constructions that are potentially vulnerable. But how do we use that? Or which are the applications that use it? Or which tools can I use to do that? So here I'm suggesting some tools for you that you can use, and there are most popular ones for this task. So all these tools implement some type of static analysis, source code analysis that investigate the applications in some sense. So if you are coming from a programming background, probably you have heard about some types of them. For instance, the lint, right? The linters, they are there to ensure some quality and some standards in the way that you code, declare variables, variable names, indentation, apply the code style to your application. Here we are taking this to the next level and not only checking these styling issues, but also the code quality itself, if the code follow the security templates and so on. So you have all those tools, right, that you can use. As you know, for the assignments here, you are free to use any one of these tools. You have completely freedom to do that. Once you complete the assignment, you are fine, right? So I'm not here saying to use one tool or to another tool in most of the cases, except when I cover the tool itself in the slides, right? But you are free to try all of them. And also for the project, right? Because you can apply these two tools to the final project as well, right? So basically, feel free to select the tool that best fits your project, the programming language of your project, the dependencies of your project, and then you can use these tools to help you to triage the vulnerabilities that you're going to inspect in the applications that you are working with in the project, right? So you can get some of these tools. You're going to investigate one of these tools in this class today. But how these things can be used in practice? So the best way to use, if you come from a programming background, is to integrate these in the CI/CD pipelines, the continuous integration, continuous development, or continuous deployment pipelines that are basically, to give you clear names, like GitHub Actions, right? So you have the workflows that when you commit a code, you run some types of checks and other things. So you can run a build command that actually creates a release for the project that you have automatically. You can run the linters. And here, what's the proposition that we from the security community are making right now is to also run the security source code static analyzer tools on the CI/CD pipeline. So integrate this, make this part of the secure development lifecycle. So when you're coding your application, one of the tests that you have is also security testing. And then if you integrate this in your pipeline, when you commit, the security check is triggered immediately, and then the code is only released if it passes the security testing. So this prevents one from releasing a vulnerable binary, right? A vulnerable code, at least with one of those most common, most trivial vulnerabilities. There's still always corner cases, right? There might be a particular construction, a particular vulnerability that is very hard to spot that might escape. Well, this always happens. That's why we are doing research to minimize these cases. But when you're talking here about a baseline of 99% of the cases, all the OWASP top 10 vulnerabilities, basically these tools are able to detect them, to cover them. And that's the idea, that if someone commits something, well, security testing is performed before you release the application. So it's pretty interesting if you can integrate this in the CI/CD pipeline, because once again, we release the programmer from the need of from being a security expert. In this case, if someone's configure a security testing, someone more skilled, for instance, an expert in security, configures our CI/CD pipeline to perform security testing, all that the programmers have to worry about, to care about, is to write in their code, because when they push it, when they commit their code, automatically the security testing is run and then gives back the results to the programmer saying, hey, you did your code is passing like the functionality testing, but in the security testing here, there is, for instance, a buffer overflow. So you have to fix this, make another commit to fix this before we release the code. That's the idea, that's the ideal life cycle of a software nowadays, right? So basically, we can use this type of static analysis tools for this purpose. So this slide describes exactly what I'm talking about. So initially, we run a static analysis tool, whatever it is, over a source code, whatever it is, and it's going to give, for instance, the report of a vulnerability. For instance, in this case, a SQL injection vulnerability was identified in a given file. And then the programmer has to go there and say, okay, let me rewrite this query, because in the original query, as you can see, I have a SQL injection. Now I notice I need to do this some other way to perform some types of checking, and then send the code again. The code is rescanned. If the vulnerability is not present anymore, the vulnerability is accepted, right? So this is a good practice to include the security checking into your code, right? Depending on the standards, depending on how critical is the software that you are creating, this might even be mandatory, right? You cannot even release any binary without security testing. For many security standards, it's a requirement to run the security testing before you release any version of your application. What are the problems that we have doing this? Because so far, so good. Everything looks great, looks beautiful, and that it's the solution to all problems, right? But we know that in practice, there is no such a bulletproof approach. So we still have some problems. So the first problem is false positives, when the tool is indicating that there is a vulnerability when in fact there isn't, which some might believe that's not a big problem because, well, that's okay. The tool is just being aggressive and it's better preventing than remedy, right? But this is in fact bad because if you produce a lot of false positives, you undermine the confidence that the programmers have in the tool, right? Because the programmers are going to believe the tool is not useful because, well, the tool is always giving me wrong indication. So false positives are not good to this sense. And also false positives are not good because if you have false positives, you have to ask the security expert to disambiguate, to solve these false positives, to tell you the truth that, oh, is this a true vulnerability or is this a false positive? So this eliminates the advantages of automating things with this type of static analysis tools because the human is put in the loop again to fix these false reports, right? So this undermines the advantages of the software. And the same happens on the other side, in the false negatives, because if the tool is not actually identifying the vulnerabilities, the tool is being very lenient and letting many things to pass, you are still releasing vulnerable code, right? That's makes the tool purposeless, because if the tool is not helping, why are you using the tool, right? So you have to find a very good calibration between not reporting too much, not reporting wrong stuff, but also not to let things to pass. So this is the whole challenge that we have here, right? And basically, that's why we do research to identify how's the best way to do that. Other things, of course, when you're running these tools, you are making the builds slower because now you have to run an entire security testing before, after you compile the code before you simply release it. So you are increasing the deployment time of your application. So you have to accept that. You have to have in mind that, hey, security is a requirement. Security is as important as everything else, right? So the time that I'm spending here running the security test is not a waste of time, but it's something very critical to my software that I need to run. And then I'm going to get results and then prove someone that, hey, I did the best that I could do. I run all security testing to the best of my knowledge. I don't have any trivial vulnerabilities, right? As we have seen this in these courses, sometimes people don't privilege security over other things and then release versions without the security testing. And we know all the problems that it causes, all the vulnerabilities that we studied in this course so far. Another problem that we have, and this is more a usability problem, more in the practice, that although we have all those source code analyzers, the tools that I have presented in the previous slides, they tended to be programming language specific, right? So each one tends to cover to be an expert specialized in its own programming language. But modern software is not built of a single language. It's composed by multiple languages, multiple frameworks. There is a JavaScript in the front end that communicates with the Python backend that runs a Java plugin in some part. And then to analyze a real software, you have to analyze the security vulnerabilities of all components written in different languages. And in many cases, there is no one-size-fits-all solution. There is no solution that covers all languages. And then people have to spend time deploying, the pipeline to each one of the components, the pipeline to each one of the languages. As you can imagine, requires multiple expertise in different languages, requires a lot of time to configure the pipeline. So this is more a usability problem, another trade-off that we have to deal with. So if you want to have, for the future, automatic code analysis, these tools are going to provide, but you have to spend time configuring these tools. And this is where we are doing research in the field nowadays. I always like to present to you what's the research in the field, what you are trying to do in the field. This is one of the the trending topics right now, research topics in this field, that is, okay, how do we make a single tool to analyze everything? How do I make the analysis of complex software composed by multiple components viable, practical, and fast and efficient? So that's what we are studying right now, to make these type of tools that I'm presenting here each time more and more viable, right? So basically, as I said, the best practice is to adopt this type of solution, to configure it properly. Do not skip the security testing, but to integrate this to a pipeline. But to that, the team, the development team needs to buy the idea that security is important because we are introducing another step in the development pipeline. This step might help a lot because this step is going to automatically check for security issues for you, but there is a configuration phase that people must perform, right? Okay, so let's go more practical in these things. So far, we present the concepts, we present the ideas, how they should be used. Let's talk about the tools itself, how the tools work, how to run the tools, all these type of things. As I can't present all the tools together, I chose one of the tools to talk about. That's one of the state of the art right now, one of the most popular tools. That is CodeQL, right? That CodeQL is basically a tool created by GitHub, right? So basically, it follows this idea of, okay, let's integrate in our platform, GitHub, that's very popular, a security analysis tool so everyone can benefit from this security tool. That's the idea. And what's the idea? The idea is to transform the code into a database that you can query using a language like SQL, like you query databases for data, you query the database for code. So you're somehow transforming the application from code to some kind of data stored in a database. When I say transform, it's not actually a transformation because you're not compiling the application to databases. That's not the point. The point is that we get the application, we analyze the snippets of the application, and we represent, that would be the better word, the application as code. So we are going to have a database, and in this database, you can ask things. All that you can do by reading the code, of course, you can check, oh, is there a function called this name, for instance? You can do this by reading the code, inspecting the code, but the idea, as I said here, is to automate the task. So basically, this is going to create a table with all function names. So to discover if there is a function called a given name, you don't need to read the entire code. You just need to check the tables with the function call names and say, oh, is there a function called this? And then it's going to check that table to tell you if there is a function called that in that table, right? That's the idea. And it can be used by a myriad of things. As I said, directly vulnerability detection when you integrate this in the CI/CD pipeline, or you can run this in a standalone manner. And as I said, the last topic is the most important one. It covers all the OWASP top 10 vulnerabilities, right? So all the most common things are covered by all these tools and CodeQL included. So that's great. All these things that you are studying in the course, we somehow, to some extent, we can get them scanned for using this type of tools, right? So what's the idea? Well, if you integrate CodeQL in your application, or if you run this standalone with a Docker installation, for instance, or a local installation, the procedure that runs under the hood is basically the same. So you're going to install CodeQL, you are creating a database with the CodeQL. In the end, it's basically running a command, right? But what it's doing is that it's going to create a database saying, okay, this is the application, these are the functions in the applications, these are the arguments in the application, these are the strings in the application. So it starts to slice in the application into its component and creating database, for instance. And then you are going to write the query saying, okay, what do I run to search? For instance, oh, is there this given function here? Is there a variable named this here? Is there a variable named password, for instance, in this code? So you have to write the queries. In practice, CodeQL is a so popular solution that you can simply get a bunch of popular queries from the internet because many people wrote CodeQL queries over there and make them available. So you can use your own queries or you can import this expertise from someone else. This is the advantage of having a tool rather than having another human expert, because here you can import the knowledge from this other human because the other human, the expert, the analyst, wrote the rules, and now I'm importing the rules in my solution. And then I run the queries to identify, for instance, if there is a variable with a password inside the code, right? And then finally, optionally, but very recommendable, it's basically you can integrate this with CI/CD, as I said, integrate as part of your pipeline. So to give some example on how this works. So basically the CodeQL has its own syntax. As I said, it looks like a SQL structure, but it is a little bit different, not very hard to get, right? The syntax, I'm not concerned here about teaching you the right syntax, because the syntax is something that you can simply ask ChatGPT to get the syntax. I'm most concerned here, what I'm trying to do here is to teach you the concepts, right? So to teach you how these things work, right? So basically, in the first one, we are importing CPP. Basically, what you are doing here is to tell that, oh, this is the environment that you have to analyze. And from the C code, the function that you have, check targets that are basically the functions that are called targets. So what are the libraries? What are the functions that are called? Is there a function that has named system? Because I want to know if this application should run third-party process or not. So is there a call to a system API or not in this in this code? And it's going to tell. So we can do this for other environments. For instance, we can use this for PHP as well, because this CodeQL supports a few, that is the most popular languages. And then you can see, once again, in the target, in the function, right? So the function that I'm called, is there a function, MySQL query, and in the arguments of this function, there is the percentage s. That means it's a SQL query and I'm taking external commands. So if this is happening, it's potentially a SQL injection. So probably the construction that we would like to have is a prepared statement, not a directly string formatting as this. So you can find it for this type of things. Or other types of things that, for instance, for every function that you have, you can check if is there a function that is called 0 times. So if there is a function that's called 0 times, it's a dead function. You use the function, a dead code, as we call, right? And this is referred here as code quality, but this has security implications as well, right? Because we learned from the return-oriented programming classes that the attacker is going to search in the memory of your application for things that can be reused. So this application here is present in the memory of your application, and it's not doing anything, right? So it's just increasing the attacker chances of succeeding, and it's not adding any new functionality. So it's not a good idea to have this function here. Maybe we can remove this function from the application since it's not used. So we reduce the chances an attacker has to find something in the memory to reuse, right? And once again, it follows the CodeQL syntax. The CodeQL syntax you can learn by yourself. It's not so hard. As I said, ChatGPT can teach you the syntax. The important thing is to know what to search, what to look for, right? And if you reach the latest step, after you created all these things, after you understood how CodeQL works, after you have your queries, you can automate all these things, putting this in the CI/CD pipeline. So this is more specifically for GitHub. It's a GitHub action. You write this YAML file, right? Saying, okay, when there is a push, right, in the main branch, every time this happens, what you are going to do is that you are going to run an analyzer jobs that has some steps that do some things. Some things are triggered, right? And some of the things that are triggered are the analysis, as you can see here, by CodeQL, right? So basically, you're going to run CodeQL every time someone pushes on the main branch, and then we are going to have the result automatically there. So we can already configure this in GitHub right now, and then CodeQL, the previous step, are going to be automatically performed to you, right? So that's the stage that we'd like to take security for all applications in all cases. Tools that we can automate, and then you can bring security expertise to your project, right? So there are some more advanced things that we can do, and then places that you can search for. I'm not going to cover in details these things. I would like just to make a final recap to wrap up all that we said, all that we talked about. First, we talked about CodeQL and about general aspects, and then about CodeQL for the general aspect. Once again, we talked about static and dynamic source code inspection. Here we are talking about static analysis that are very cheap, very fast, very flexible, so that they are the first line of defenses against vulnerability, right? we are creating tools to help us, so we can import expert knowledge in the form of rules that runs in these tools, and we can integrate this with the CI/CD pipelines to make it easily available to everyone, such that when any programmer commits, any programmer pushes, we run a security analysis before we release the application, and we only release it if it's safe. If it has a known vulnerability, like the OWASP top 10 ones, we refuse to release and ask the developer to fix that vulnerability. We can use many tools for this test, but the tools that we used here was CodeQL. That basically, it's the most popular one, can be used standalone, is integrated with GitHub, so you can play with the GitHub. There are also Dockers and other installations available over there. So my best suggestion at this point is to try to download CodeQL and start the play. Of course, this is one of those topics that I could give an entire course on. I don't expect anyone to become an expert in CodeQL after these few slides, but it's raising your awareness to know that these type of tools exist, and maybe you are going to use these tools in the future, right? So to give you some demonstrations on how those things work, I would like to go here to show you that I have the buffer overflow here from the previous assignments, right? Okay, my computer froze. Interesting. Let me connect again. Okay, connected again. All right, so you have the same buffer overflow as in previous classes. So you know the buffer, you have the string copy, vulnerable version, reading from the bad file. You know this code, right? So I have the code here, right? The code is already compiled here in the buff file. And what I'm going to do is I'm going to run CodeQL from a Docker. So we have a Docker. You can download a Docker, for instance, and run CodeQL directly from the Docker. I'm going to run CodeQL this way that you can see here. That's basically I'm saying, hey, get the files in this directory and then analyze these files, then store the results here. Again, basically, I'm giving the language as CPP, as you can see here. So it's going to analyze C files and outputting a CSV file. And basically, CodeQL is going to do the magic for us. So when you push it to this repository to say so, CodeQL is run. And then it takes some time, as you're going to see here. It's going to run the queries. It's checking for a bunch of vulnerabilities. As you can see here, these numbers are the number of vulnerabilities that are being inspected. And then after some time, it finishes the evaluation, puts the result and say, okay, analyze the code of the files that you put there, that in my case was the buffer overflow, and I saved the results in this CodeQL results CSV. So basically, if you check the CodeQL results CSV, basically what you're going to have is a summary of what are the security risks for this application. That, as we can see, is what you are expecting. That is buffer write operation that do not control the length of data written in the buffer, right? And the call to string copy with the input might overflow the destination, right? In the buffer overflow.c file, right? So if a programmer created that code completely unaware that that was a buffer overflow, the programmer would receive, after running this type of static source code analysis, this type of result, right? And then, of course, you can run this to the files that you are using in the project, in the applications, right? So to exercise this, what I expect you to do is, let me go to my window to show the assignment for this time. It's basically run the CodeQL Docker, or can be your local installation as well, but I'm suggesting the Docker where everything is configured. And basically, if you configure the Docker to do that, you can inspect the application. You can inspect in a previous application, can be the buffer overflow, as I demonstrated here, can be the ROP, can be the return-oriented programming, the return to libc, can be the SQL injection, can be the cross-site scripting. You can put the scripts, the code, the projects that you created previously that were vulnerable, configure the target languages, at least one project, at least one language that shows something. Basically, that's the message. And then you show the CodeQL running and the vulnerability being identified. And after you did this by yourself, and then you do the easiest way, that is, create a GitHub repository, configure CodeQL in this repository. That's much easier. It's basically the YAML file. You don't need to configure the entire Docker, right? And then when you push the same code vulnerable here that you used in the step 1, you are going to see in the step 2 GitHub notifying you that you are pushing a vulnerable code, right? That's the assignment. That's what we have to do for today. Thank you once again.